Hello, this is the luckiest maths teacher in the world. Today we're going to look at factorization. Now last time we did binomial expansions, so we did things like this, x plus 3 times x plus 1, and we found out that that would equal, once you collect like terms, x squared plus 4x plus 3. So what we were doing yesterday, we were starting with something like this, and going to something like that. We were taking away the brackets and their expansions. That's why I called them binomial expansions. But what we're going to do today is we're going to start out with something like this, something that has no brackets, and we're going to write it as something like that. And that way is called factorization. So if you expand something and then factorize it, you end up where you started. So in other words, factorization and expansion, they are things that undo each other in exactly the same way as division and multiplication undo each other. So we're going to look at how we go about doing this. So there are a few methods we're going to go through today. The first method is using highest common factor. Now that's the easiest one, and I want you to always try that one first. First see if there's a common factor. Then we're going to look at difference of two squares, and we're also going to look at grouping. So I'll do them one after the other. Okay, so we did a little bit of the first method before, so that should be a recap. So let's look at the first method and some examples. So let's say I have something like x squared plus 4x, and I want to factorize this. What I want to do is I want to write it as something that looks like this. It will have brackets, but factors are things that multiply together. So I want to write this as something times something. And this answer I get, I should be able to expand it and get what I started with. So what I do is I find out the common factor in both terms, or there may be more than two terms. It has to be a common factor to every term. Just as a quick aside, in case you don't remember, terms are things separated by plus and minus sign. So this is a term and this is a term. So they have a common factor of x. So what I do is I write x in the first box. So that should always be in the first box, should be the highest common factor. Then what I do in the second box is I put brackets like this, and then I go to each of the original terms and I say, what do I need to times by x to get that term? So in other words, the first term here is x squared, and I've taken out a factor of x. So I think, what do I need to times by x to get x squared? And the answer is again just x. Then I go to the second term. What do I need to times by x to get positive 4x? And the answer is just positive 4. Now, when you do this, what you have in the brackets should have no common factors. Otherwise, you haven't fully factorized. So x and 4 don't have any common factors. There's nothing that goes into both of them. So I know I've done something right. So if you're unsure of whether you got the right answer, you can expand your answer and see if you get the original question. So I go x times x equals x squared, and x times 4, or positive 4, gives me positive 4x. So this is the same as my original question, so I know I've done something right. Let's do another example a little faster. So let's say I have 2x squared plus 14x. Now here, the coefficients 2 and 14, they have a common factor, and that is of course 2. So I take out 2. But x's appear in both terms, so I also need to take out a factor of x. 2x is the highest common factor. So what do I times by 2x to get 2x squared? It's just x. What do I times by 2x to get 14x? Another way you can think about that is 14x divided by 2x, and the answer is positive 7. And again, no common factors with the stuff in the brackets, and if I expand my answer here, I get the original question. One more example. Let's say I have 9x squared minus 3xyz. Okay, I'll actually make the first term 9x squared y. So highest common factor, so we do it individually. So the highest common factor of 9 and 3 is just 3, so take out 3. Each of them has an x. I can't take out more than one x. I can't take out a factor of x squared because this one only has one x. So take out an x. There's also a y in each, so take out a y. So first thing I do, in the brackets, what is 9x squared divided by 3xy? Or in other words, what do I times by 3xy to get 9x squared y? And the answer is I times by 3 to get 9, and I need to times by x to get the x squared. And then what do I times by 3xy to get 3xyz? Well, I'm almost there, but I just need to multiply by z. And of course, to get from a positive to a negative there, that has to be negative. So again, if I expand this using expansions that we did both yesterday and in term 1, I will get my original answer. Easy. Now I'll show you the next one, difference of two squares. So please copy down if you need anything on this slide. So I showed you yesterday when we're doing binomial expansions, if you have something like a minus b, and then you times by a plus b, you get a middle term cancelling out, and it equals a squared minus b squared. That's what we did yesterday. Today, because of what we did yesterday, we know that if we have anything like this, and we want to factorise it, it's just going to look like that. So for example, x squared minus 4. So you think to yourself, this is one square divided by another square number. So I go in the brackets. I know it's going to look something like this. So what do I square to get x squared? Of course, is x. So I put an x at the front of each brackets. And then what do I square to get 4 is obviously a 2. Or if you like, the square root of 4, and then one has positive and one has a negative sign. It doesn't matter in which order. It doesn't matter if it's x minus 2 times x plus 2. Okay, so let's look again. Let's say I have x squared minus 25. So that would just be x minus 5, because I square x to get x squared, square 5 to get 25, times x plus 5. Let's say I have 9x squared minus 36y squared. Okay, now this one here, 9 and 36 have a common factor. So as I said before, if that happens, first take out the common factor. In this case, it's 9. And then I'm left with x squared minus 4y squared. This thing in here is the difference of two squares. So what do I square to get x squared? I square x. What do I square to get 4y squared? It's 2y. So it'll be x minus 2y, x plus 2y. Just like that. Now sometimes you will get something that doesn't look like difference of two squares. So let's have 2x squared minus 32. Okay? Now 2 and 32 are not perfect squares. But if we do what I said and we take out a common factor, they will become difference of 2 squared. This will become 2 outside of x squared minus 16, and that's very clearly difference of 2 squares, x minus 4 times x plus 4. Now please note, this is difference of 2 squares, not sum of 2 squares. If I have something like x squared plus 36, I actually can't factorize that. There's no common factor, and it definitely doesn't equal x minus 6 times x plus 6. That is wrong. So they have to have a minus sign between them. Okay, I will now show you the third type of factorization, that we're going to learn today. So what we're going to do now is we're going to look at grouping in pairs, and this is where you have, say, 4 terms. And what you do is you group them in pairs. You factorize the first 2 terms separately and then the last 2 terms separately. So let's say I have something like this. X squared plus 4x plus 3x plus 12. Okay? Now, I could obviously make these two into a 7x, but then I don't know how to factorize x squared plus 7x plus 12 yet. We haven't covered that. So what we'll do, we'll factorize the first 2 terms using highest common factor. So x squared and 4x, the common factor is x, and then in the brackets x plus 4 Now I'm going to look at the next two. And the common factor there is just 3, not 3x. So 3 outside of, so 3 times x gives you 3x, and then I need a 4 to get to the 12. Now what I have here is actually two terms with common factor. So this x plus 4 is common in both terms. So just like I did in the previous question, I take out the common factor, even though it looks a bit different. Now what goes in the brackets? So what do I times by x plus 4 to get x times x plus 4? Of course, that's just x. What do I times by x plus 4 to get the whole thing here? And of course, that's just positive 3. Okay, done it there. Sometimes it'll be a little bit different. You won't have just x's. So let's look at another example. So let's say we have something like this. Now these four terms, certainly they're not the difference of two squares. There is no factor common to all four terms, so we can't use the HCF method. There are no like terms, so we can't simplify this expression. But we can use our good old grouping in pairs. So let's do the first two. The common factor is a, and then in brackets is just a plus 6. And then in the second one, I'm actually going to take out a factor of b, because it's common, but of course I'm going to take out minus b to make things easier. So what do I times by minus b to get a? That's just, to get ab, sorry, that's just a. Minus b times a gives you minus ab, and then it's a positive, because a negative times a positive gives a negative, it's a positive 6. And again, I use the same trick that I used up here. This thing in the brackets is common, so I take it out the front, and then what goes inside the brackets is just what's left outside here. So a minus b, just like that. If you expand this using FOIL, you will get that. I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.